Welcome back. Let's practice working with inequalities. All right, so here's our first example. We want to plot the inequality on a number line. And our given inequality is x is greater than 2. And so to plot this on a number line, the first thing we have to do is draw a number line. So I'll draw mine like this. In the middle, I'll label the value of 0. And then what you want to look at is the number that is being compared to the variable of x. In this case, we're comparing x to 2, so we want to make sure to include that number of 2 on the number line. All right, and so remember, as you move to the right from 0, you have positive numbers, and as you move from 0 to the left, you have negative numbers. So let's say that this is 1, this is 2, and this is 3, and then negative 1, negative 2, and negative 3. Okay, and so that's our number line, and we did include 2, specifically positive 2, the number that our variable is being compared to. And at that number on the number line, we want to draw a circle, and it will either be an open circle or a closed circle, depending on whether that number is included or not. And what I mean by that is, would this inequality be true if x was equal to 2, right? If you replaced x with 2 in this inequality, would it be a true statement? Well, no, because 2 is not greater than 2, 2 is equal to 2. All right, so 2 is not included as a solution to this inequality, right? That's really what we've been given here. This is a solution set for an inequality. It represents the values of x that would make this a true statement. And so 2 is not included in that, which means that we want to draw an open circle at that value of 2 on the number line. If 2 was included, if this was instead x greater than or equal to 2, then we would draw a closed circle, meaning that we would fill it in, and that would indicate that we're including 2 in our plot here. Okay, but we're not including 2 because it's x greater than 2, and so our plot starts at 2, not including it, but then we do want to include all the values of x greater than 2, and so that would be all the numbers to the right of 2 on the number line, right? 1, 0, negative 1, all of these numbers over here are less than 2, so we don't want to include those. We want to include all the numbers bigger than 2, so draw an arrow in that direction. And that's it. That would be the plot on a number line for this inequality. Let's take a look at another example. Next up, we want to plot this inequality on a number line. We were given x is less than 4, and so the first thing we want to do here, once again, is start by drawing a number line. And so this will be mine right here. I like to put 0 at the center. And then in this case, we are comparing x to the value of 4. And so you want to make sure to include 4 on the number line. And so in this case, we'll have 1, 2, 3, and 4. And then I'll put in negative 1, negative 2, negative 3, and negative 4. Okay, and in this case, 4 would not be included as a solution to this inequality, right? This is not x less than or equal to 4. It's just x less than 4. So we will draw an open circle at 4, just like this. And then the question is, do we draw an arrow in this direction or in this direction along the number line? And to answer that, we have to look at the inequality. What is it saying? Well, it's saying that the value of x should be less than 4, right? That's what this symbol says. X is less than 4. So we want to include all the numbers less than 4, which means that we would draw our arrow in this direction, to the left of the circle, because all of these numbers over here are less than 4. If we were to go in the other direction, we would be including numbers bigger than 4, which we don't want to do here. All right, so your arrow should go in this direction and include all of those values less than 4. Okay, and that would be our plot of this inequality on a number line. For our next example, we want to plot this inequality on a number line. We have x is greater than or equal to 0. And so let's start by drawing a number line here. I'll make mine look like this, and then I will label the center as being the value of 0, which in this case is the value that we are comparing the variable to, right? We're saying that x is greater than or equal to 0. And so really we don't need to add any more numbers to this number line, but I'll just add a couple here as a reminder that the numbers to the right are positive and the numbers to the left are negative. Okay, so I just labeled a couple more numbers, but you don't really have to do that, because what this inequality is saying is that x must be greater than or equal to 0. So since it can be equal to 0, we can include 0 in our plot, meaning that we won't just draw an open circle at 0, but rather a closed circle. That indicates that 0 is included in this solution set. Or in other words, 0 would make this inequality true if you substituted it in for x. Okay, 0 would be greater than or equal to 0. Specifically, 0 equals 0. Okay, but then we want to include all the values greater than 0, so that would be all the positive numbers. Okay, we're not going to include any negative numbers because those are all less than 0. So draw an arrow in this direction, pointing to the right, which would include all the positive numbers. Let's take a look at one more example of plotting an inequality on a number line. Here we want to plot this inequality on a number line. We have x is less than or equal to -1. So I'll draw a number line here. I'll let the middle be the value of 0. And then in this case, the value that we are comparing to our variable x is -1. And so we want to make sure to at least label that on the number line. So right here would be -1. It's a value less than 0. So you want to write it on the left side of it. And then if you want, you can label some more numbers on the number line. This isn't necessary, but I do like to add some more. So I'll put -2 here, -3 there, and then 1, 2, 3 in the positive direction. But now -1 is still the focus because we're comparing it to x. In this case, we're looking for values of x less than or equal to -1. So since it can be equal to -1, we want to include -1. So we will not draw an open circle, we will draw a closed circle. We will fill it in. Okay, so now we've indicated that -1 is included, but then do we draw an arrow to the right or to the left? Well, we're looking at values of x less than or equal to -1. So we're looking at values that are smaller than -1. So that doesn't describe 0, 1, 2, 3, and so on. Those are all numbers that are bigger than -1. So we want to draw our arrow to the left, including all those negative numbers that would be smaller than -1. So I'll draw my arrow just like that. And there you have it. That would be the plot on a number line of this inequality. Okay, let's take a look at a different example. Hey, real quick, before we take a look at the next example, if you find my videos here at JK Math to be helpful, then I'd like to invite you to join my membership site JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you'd get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. Okay, so if you're interested in becoming a member, feel free to check that out, as it's a great way to support me in the tutorials I make, as well as a great way for you to learn math better. But for now, let's take a look at the next example. For this example, we want to determine which of the following numbers are solutions of the inequality. Specifically, we want to check 1, -1, 12, and -5 for the inequality x minus 5 is less than -6. Okay, so what we have to do here to determine which of these numbers are solutions to this inequality is take turns substituting them in for x, simplifying, and seeing if the resulting statement is true. If it is true, then the number that was used is part of the solution, but if the statement is false, then the number is not a part of the solution. Okay, and so let's check these one at a time. Let's start with 1. If x is equal to 1, then we'll replace this x with 1 and have 1 minus 5 is less than -6. And 1 minus 5 is -4, so we have -4 is less than -6, but that is not a true statement, right? -4 is bigger than -6. -6 is a smaller number, so this statement is not true. It is false. And so +1 would not be included in the solution set to this inequality. It does not make the inequality true, so it can't be a solution. All right, so then let's check -1. If we let x be -1, what will happen? Well, once again, you want to replace this x with -1, so you'll have -1 minus 5 is less than -6, and -1 minus 5 is -6, so we have -6 is less than -6. Now you might be tempted to say that this is true at first, but you have to be careful. This is not an equation, right? This is not an equal sign between these two numbers. This statement says that -6 is less than -6, but -6 is not less than -6 it's equal. And so because this is not an equal sign, and it's also not a less than or equal to sign, right? That's not what we have there. This is a false statement as well. -6 is not less than -6. So this is false, meaning that -1 would also not be included in the solution set for this inequality. It does not make it true. Okay, and so let's try 12. Let's see what happens if x is equal to 12. For 12, we'll get 12 minus 5 less than -6. If we replace x with 12, this is what we get. And 12 minus 5 is 7. So we have 7 less than -6, but 7 is bigger than -6. So this is also a false statement. All right, 12 does not make that statement true, which means that 12 would also not be included in the solution set for this inequality. It's not a solution at all. And so let's check the last number here. Let's check -5. Let's see if that's a solution of the inequality. If we replace x with -5, we'll have -5 minus 5 is less than -6. And -5 minus 5 is -10. So we get -10 is less than -6. And that is true, right? -10 is a smaller number than -6. So that statement is true, indicating that -5 is a solution to this inequality. It would be included in the solution set. All right, so my final answer here is that of these four numbers that we have been given to test, only -5 is a solution. Okay, that's what we have found here for this example. Let's take a look at one more example for this video. All right, so for our final example, we want to determine which of the following numbers are solutions of the inequality, and we want to check 2, -3, 10, and 5. For this inequality, 8x minus 7 is greater than or equal to 7x minus 2. Okay, so we have a slightly more complicated inequality this time around. The variable of x is on both sides of the inequality, so we have to make sure that when we check these numbers, that we plug each of them into both of those variables of x. Okay, so let's start with +2. Let's see what happens when x is 2. So you want to replace each of these x's with 2. So you'll have 8 times 2 minus 7 is greater than or equal to 7 times 2 minus 2. Okay, and so then to compare these two numbers, we have to simplify. 8 times 2 is 16. So we have 16 minus 7 greater than or equal to 7 times 2 minus 2. And 7 times 2 is 14. So we have 14 minus 2. And 16 minus 7 is 9. So we have 9 greater than or equal to 14 minus 2, which is 12. And so our final statement here is 9 is greater than or equal to 12, which is not a true statement, right? 9 is smaller than 12. It's not bigger than it, so that is false. Okay, so 2 will not be a solution to this inequality, but what about -3? Let's check that. If we let x be -3, we'll have 8 times -3 minus 7 is greater than or equal to 7 times -3 minus 2. Okay, once again, I just replaced each of these x's with -3, the number that we are testing to see if it is a solution to that inequality. And then we do need to simplify once again. 8 times -3 is -24. So we have -24 minus 7 is greater than or equal to 7 times -3, which is -21 minus 2. So we'll have minus 2 on the end there. And then -24 minus 7 is -31. So we have -31 is greater than or equal to -21 minus 2, which would be -23. And so comparing our two numbers here, we have -31 greater than or equal to -23. Well, that would be a false statement, right? -31 is not bigger than -23. It is a smaller number. So just like +2, what we have found here is that -3 is not a solution to the inequality because it produces a false statement. Okay, so the first two are duds. 2 and -3 are not solutions to the inequality, but let's check 10 and 5. Maybe those will be different. Starting with +10, we want to replace both of these x's with 10. So we have 8 times 10 minus 7 is greater than or equal to 7 times 10 minus 2. And 8 times 10 is 80. So we have 80 minus 7 is greater than or equal to 7 times 10 minus 2, and 7 times 10 is 70. So we have 70 minus 2. And 80 minus 7 is 73. So we have 73 is greater than or equal to 70 minus 2, which is 68. And that is a true statement, right? 73 is greater than 68. And so we can check that off. That is true, which means that 10, specifically positive 10, is a solution to this inequality. It would be included in its solution set. All right, and so that leaves us with just one more number to check, and that is positive 5. So let's see what happens if we substitute 5 in for each of these x's. We'll have 8 times 5 minus 7 is greater than or equal to 7 times 5 minus 2. And 8 times 5 is 40, so we have 40 minus 7 greater than or equal to 7 times 5, which is 35 minus 2. So we have 35 minus 2. And 40 minus 7 is 33. So we have 33 greater than or equal to 35 minus 2, which is also 33. And so is 33 greater than or equal to 33? Well, yes, they are equal. Since this is a greater than or equal to sign, this is still a true statement. If it was just 33 greater than 33, it would be false. But since it is 33 greater than or equal to 33, this is a true statement, which means that 5 is a solution to this inequality. Okay? And so now we have checked all 4 of these numbers. The first 2 did not make the inequality true, but the last 2 did. So our final answer here would be that 10 and 5 are both solutions. Okay? That would be the answer to this example. And this was the last example for this video, but if you do want to get some more practice working with inequalities, I do have more available on my membership site. So if that's something that interests you, feel free to look into becoming a member. You can find all the details on my website at jkmathematics.com/plus. If you have any questions, please let me know in the comments. But if you don't have any questions, this is all I had for now. So I will see you next time.